Hey everyone, welcome to the very first video of graphs. I hope everybody of you will be liking this series, the entire series of graph which I am making from today. Today the lecture will be basics, but in the upcoming videos you will just realize that if you are watching this series there will be no concepts of graph you are not knowing. We will be covering everything from basics to advanced, so stay tuned for everything. Do subscribe to this channel to stay tuned for the upcoming videos, and also like the video if you are genuinely liking the content, and also don't forget to share with your friends. And without making any further delay, let's get started with today's video. So, before diving into graphs, I just want to explain some concepts. I guess everybody knows this, that a basic equation of a straight line is y is equals to mx plus c, and where m represents the slope of the line and c represents the y-intercept, and this can be plotted like any arbitrary line. This is the angle which the line is making with positive direction of x-axis in anti-clockwise sense. This gives us the theta, or tan theta also gives us the slope of the line, and the y-intercept is basically this one, the intercept it is making on the y-axis of 0 comma c, where c for this case is having a negative value. Okay, and also there is another form which is called intercept form, x by a plus y by b is equals to 1, where you can just see the graph like this, where a is the x intercept and b is the y intercept, where a is this one, because if this line is cutting x axis and y axis respectively at points a and b, then for a is 0 comma b, which is the y intercept, and for b it's a comma 0, like the abscissa is 0 because a is the x intercept. I guess everybody is knowing this basics, so just dive deep into the concepts from now on. From number 1, graph y is equals to x. Everybody knows this, like I guess everybody can do this. This is y equals to x. Now which comes is y is equals to mod of x. Now what is modulus function? Basically mod of x always bears a positive value. Whatever be the value of x, whether be it negative or positive, it always gives a positive value. Like if x is greater than 0, this comes out as x, the graph be like x like this, and if x is less than 0, it comes as minus x. Now if y equals to x is this line, then y equals to minus x will surely be this line. You can think it like this, or there is a concept which you may note down. The concept is basically when a function y is equals to fx is transformed to y is equals to mod of fx, we generally consider x axis as the mirror and take reflection of whatever the portion is below it. Like for example, y equals to x is transformed to y equals to mod of x, then considering x axis as the mirror, if we treat x axis as the mirror, this is the portion below x axis, right? So this will get reflected taking this as mirror, so it would look something like this. So this is the concept. Okay, if you don't know this, you may note this down obviously right now. You can note this down right now, and also in the upcoming videos there will be a separate video on this concept about the transformation, so obviously you can refer to those. Now moving on to the next graph, which is y is equals to 1 by x. This is nothing but a rectangular hyperbola. I guess everybody had read the concepts of directly proportional, inversely proportional. So we can call this as inversely proportional. Like if a quantity is inversely proportional to something, the graph is like this. So basically, I guess everybody is in class 12. For like in Coulomb's law, we know that the distance between 2 point charges, the square of distance between 2 point charges is inversely proportional to the force, so electrostatic force. So the graph would be like this. And coming to maths, this it's y equals to 1 by x, so xy equals to 1 is the equation. So this represents a rectangular hyperbola, and this x axis and y axis are basically asymptotes, acts as asymptotes. Now what are asymptotes? Asymptotes are basically tangents at infinity. Like this graph, this is tending to in some infinite distance. Okay, now we can consider that this x axis is at some infinite distance, probably may touch the graph at some point like this. Maybe there at infinity, this is the concept for asymptotes. Now two very famous graphs, y is equals to let me generalize this, x square is equals to 4ay and y square is equals to 4ax. Now what is this 4a? You will learn in parabola. For now you can treat it as a constant whose value is equals to 1. So just take it like x square is equals to y and y square is equals to x. Now x square is equals to y is having a graph. Just remember the concept. The one having the square and is basically the one having the square, it will not be axis of the parabola. These are the basically parabolic functions, or basically for example, if we take any quadratic equation, for example y is equals to ax square plus bx plus c, कोई भी क्वाड्रेटिक इक्वेशन का ग्राफ एक पैराबोला रिप्रेजेंट करता है, ठीक है, और इसका भी ऐसा ही होगा. सो इसका होगा एक अपवर्ड पैराबोला जिसके ऊपर स्क्वायर नहीं रहता, वो अपना एक्सिस होता है पैराबोला का. यहाँ पे एक्स के ऊपर स्क्वायर नहीं है, मतलब वही एक्सिस होगा पैराबोला का. तो ग्राफ कुछ ऐसा बनता है, ठीक है. ऑल्सो रिमेंबर दैट दिस इज ऑल्सो अ क्वाड्रेटिक इक्वेशन. सो दिस इज हाउ लाइक वी understand like algebra. The things are all related, whether be it algebra, coordinate geometry, everything is related. So let's now move to the next graphs. Now the graphs are trigonometric graphs. We will be dealing with three main trigonometric graphs, that is number 1 y is equals to sin x, 2 y is equals to cos x, and number 3 y is equals to tan of x. Now y is equals to sin x, the graph is like, it's just like a wave. Basically this is 0, pi, 2 pi, 3 pi, 4 pi. So this is sin x, whose maximum value which sin x can obtain is +1, and the minimum value which sin x can obtain is -1. Everybody knows this. Now this is the graph of sin x. It's like a wave, and this is a periodic function. What is a periodic function? A periodic function is one which repeats its graph after a fixed period. For example, this sin x, after every 2 pi, just check, the graph is getting repeated. This is minus pi, minus 2 pi, check, minus 2 pi to 0, a period. 0 to 2 pi, same graph is repeated. 2 pi to 4 pi, same graph. So this is having a period of 2 pi. These are periodic functions. Okay. Now cos x. Cos of 0 gives us a 1. So the graph will start here, and cos of pi by 2 gives us a 0. So the graph goes like same here. Okay. Let me write this pi by 2 very clearly. Pi by 2, this is minus 1, cos of minus 1 is basically this, so this is basically pi, this is 3 pi by 2, and this is finally 2 pi. Cos 2 pi gives us a 1. Okay. So this is also having a period of 2 pi. Just check. This is also minus 2 pi. See, minus 2 pi to 0. Graph is like this, then again graph is like this. This is y is equals to cos x. Now coming to y is equals to tan x, people often have confusion in understanding this. Tan of 0 is 0. Now comes pi by 2 and minus pi by 2. Tan of pi by 2 is called undefined. Basically the graph tends to infinity, whereas tan pi is again a 0, and tan 3 pi by 2 is again tending to infinity. So the curve be like this increases. So the curve increases in 0 to pi by 2, and at pi by 2 it tends to infinity. At minus pi by 2 it tends to minus infinity. The curve is like this, and this graph gets repeated. At this is 0, so same like this. At 3 pi by 2 it tends to infinity, and at pi by 2 it tends to infinity. Like this the graph gets repeated. Similarly in x direction, similarly in y direction. Like after every pi, like for example at pi it is 0, so 0 it tending to infinity at 3 pi by 2 and coming from minus infinity, because we don't know whether the value it is tending to minus infinity or infinity. So basically it's undefined, so the graph behaves like this. So these are the basic trigonometric graphs. Let's get to logarithmic ones. Now before starting the logarithmic ones, let's discuss a small concept. Like we know y is equals to sin x, or we can write this as x equals to sin inverse of y, and if we just replace x and y, we can write this as y is equals to sin inverse x. So this is a function and this is a function. What we did, we just represented this in terms of x and just changed x and y, replaced x in place of y and y in place of x. So these two are basically inverse function of each other. Okay, these are called inverse functions, where if this is having a domain of d and range of r, this will have a domain of r and range of d. This is a concept, and these are basically the graphs of these two graphs are reflection about the line y is equals to x. For example sin x का ले लीजिए आप, sin x का ग्राफ कुछ ऐसा रहता है ना 0 से 2 पाई में. In 0 to 2 pi the sin x b is like this. This is y is equals to x. This is y. So sin inverse x graph is something like like this getting reflected like this and this getting reflected like this. I know this is a little difficult to imagine, but this happens. So now let's dive into logarithmic function and I will make you understand why I taught you everything like this. Let's dive into logarithmic functions. Y is equals to log e base x or ln x. We can call this as ln x. Now if we take anti-log, it's x equals to e to the power y, or if we just exchange between x and y, it would be y is equals to e to the power x. So you can understand from this that ln x and e to the power x are inverse functions of each other. So if we obtain graph of one, we will surely get the other by taking deflection about y is equals to x. This is my y is equals to x. For ln x, the graph goes like this. Y is equals to ln x. If I represent only ln x, it's like this, where this point is 1, 0. Now if we take the reflection, this would surely pass through 0, 1. For this portion, if I take the reflection, it would be like, it is also coming from this side, and for this portion, like for only this portion, the graph will come, touch this, and for this portion it will be like this. So this is y is equals to e to the power x, or if I just represent y is equals to e to the power x is like this, where this portion is 0, 1. Now let's see some special functions. Now let's discuss a special kind of function which we call as greatest integer function. Maximum time we generally get confused with this function, but I guess after today's lecture things will be clear. Now what is greatest integer function? Greatest integer function of x is represented like this. Let me explain this with some examples. Basically, greatest integer function returns a number which is less than that particular number if the number is having a decimal point, or I can say it like this, like 2.3, this will return as 2, just the previous number, previous integer, greatest integer, previous integer. Or for example 2.7, even this also returns as 2, just the integer below. For example minus 1.3, the integer which is less than minus 1.3 is minus 2, or minus 9.8, this will also give us the integer which is just less than this one, which is minus 10. So this is the concept of greatest integer function. It returns the greatest integer which is just less than or equals to that particular number. Equals to, when I say, I mean for example gif of, this is also called as gif. So gif of 2 is called 2, it's 2 itself, or g of minus 2 is also minus 2. This is what greatest integer function is all about. We have to understand its concepts, and also this is a property of greatest integer function, that if any constant is added to this, then it will come out of GF like this. Any constant number. Also, there is one thing, any number x can be written as a combination of greatest integer function and fractional part function. Now what are these? This is greatest integer function, this is fractional part function. This can give a value which belongs from 0 to 1. 1 is not closed, it's rather open interval because it can't return 1. Okay, and that returns integer, as we all know. For example, 2.5 can be written as this will give us a 2, this will give us the fractional part, that is 0.5, which if we add we will land up here. Now let's see the graph. It was very important to go for the basics before we jump to the graph. Let's do for only this much, the rest things will be cleared. If my number lies between 0 and 1, then obviously greatest integer function will be 0. Okay, so at 0, GIF of 0 is 0 itself, and until 1 it is 0, like this. And but greatest integer function of 1 is a 1, so here there will be a open one, and for 1 we will get here 1, for 1 we will fill it here. Similarly, any number lying between 1 and 2, its GIF which will always be 1, and also greatest integer function of 2 is 2. So similarly we will draw this, like for till 2 the value is maintained at 1, at 2 this is not 2 because GIF of 2 is the number 2 itself. Now coming to the negative side, let's go for 3 also. For 3 it's coming like this, and on 3 it would be an open one. Now for any number lying between 0 and minus 1, this will always be, GF will always be minus 1. So for any number lying between minus 1 and 0, so this is minus 1, so for numbers lying here, this would be, for minus 1 it's minus 1, and at 0 here it would be a open, like this. Similarly, if this is minus 2, for minus 2 it's minus 2, gif is minus 2 until it goes to minus 1. So like this is it's a ladder like function. It's just like a ladder, step by step we are going. Gif of 2 is 2, gif of minus 1 is minus 1, gif of 0 is 0. When we are obtaining a value, it's a fully dotted, and if it's not there, it's a hollow circle. I guess you got your concepts cleared from the graph, and just take a screenshot or note this down somewhere, because this is very important for us to understand. Guys, just quickly note this properties. These are really important, and I just thought that although we are discussing graphs, but we must know these properties. Let me just tell you these properties once more. I have already told this one, that if n belongs to natural number and it's added to greatest integer function of x, this n just comes out of the gif. Minus x, if it's integer, it's minus of gif x, and else if it's not an integer, it's minus 1 minus of gif x. For fractional part of x, this n just vanishes away. Same, n belongs to natural number, and for minus gif x, it's 0 if it's an integer. Obviously gif of any like fractional part of any integer is a 0, and if it's not an integer, it's simply 1 minus x. Just take a screenshot, and let's now go to fractional parts graph. Now let's come to the graphical part of fractional part function. Now we have seen that fractional part of any integer is 0, and the value of fractional part of x always lies between 0 to 1. It can never be 1. Okay, so let me first plot 1, and this will be the line of discontinuity of the function. So let me just make it like this. Now 0, I will make it as symmetrical as possible. 0, 1, 2, minus 1, minus 2. Now let's see. From if the value increases from 0 to 1, this graph goes like this, and finally at 1 it is an open circle, because at 1 it is 0. Basically, for values of x, the value it's increasing, like for 0.1 fractional part is like 0.1, like this it's coming. So it is like this, it is a straight line which is going till 1, at t at 1 it is discontinuous, and at 1, since it is an integer, the value is a 0. Again for 2 also we will mark it as 0. For minus 1, for every integers we will be marking it as 0, and it will be always discontinuous like this. So from 1 also similarly the graph will go like this. At 0 also it would be 0. From here also the graph will go like this to 1, and this will be an open, this will be open, this is also gonna be open. Like this it happens. For the giving in, for like just analyze the situation. For the every given input, values are increasing, but when it is reaching an integer, it's just a 0. Just refer to this graph also. This line is y is equals to x, you can see this line is y is equals to x plus 1, so obviously this will be y is equals to x minus 1, and it goes like this. Copy this one, and next we will go to the next function. Coming to the last type of special function, which is SIGNUM function. This is there for JEE Advanced. Also, maybe you will find its stresses in JEE Mains also. Whatever our motive is to learn. So we represent this as signum of x, whose value is mod x by x, x not equals to 0, and x equals to 0, it's always a 0. From this also you can just see. So if x is greater than 0, then as signum x will be x upon x, because mod x will give us a x, so this will be 1. So 1 for x greater than 0, for x equals to 0 we have already seen it to be 0, and for x less than 0, signum x is mod of x by x. So as this x is negative, it will come out with a negative sign after the mod goes, because the modulus function always returns a positive value. So this will go, minus x is coming out, which is giving us minus 1. So it is minus 1 for x less than 0. So the graph goes like, we have 3 points, 1, minus 1, minus 1. For x equals to 0, it's 0. For x greater than 0, it's always a 1. So it would be open at 1 and it will be going like this. And for x less than 0, it's always minus 1. So open at minus 1 and going backwards. These are open. This is the graph of signum function or signum x. Note it down. I hope this video was very helpful for each and every one of us. Like every one of you who watched this video. This was the basics of graphs. Like these graphs you must know to move forward, step a bit forward. Now upcoming session there will be problems from JEE, from various competitive exams, and also we will be coming out with some new concepts, and obviously the content will be from basics to little advanced, because next day this would be a little higher. So stay tuned to this channel, subscribe to this channel to, if you like this video, to also get updated about my next video on of this graph series. And until then, goodbye. I'm signing off for the day.